In the medical world, moisture is the enemy of stability. Traditional surgical glues, they fail the moment they touch blood or wet tissue. But in the damp undergrowth of European forests, the Dusky Arion slug has already solved this multi-billion-dollar engineering problem. This isn't just slime, it's a sophisticated, tough adhesive comprised of 90% water, yet capable of sticking to a moving, wet surface with more force than industrial epoxy. Engineers at Harvard's Wyss Institute didn't just copy the slug's slime, they decoded its molecular architecture. The result is a revolutionary double-network hydrogel. Here is why it's a game changer. Traditional surgical adhesives are brittle. They crack under pressure. But this bio-inspired glue is comprised of two intertwined polymer networks. One provides a stiff framework to absorb energy, while the other remains highly flexible, stretching up to 20 times its original length. Unlike the rigid stitches or steel staples used for centuries, this hydrogel doesn't just sit on top of the tissue. It forms three distinct bonds: electrostatic attraction, covalent bonding, and physical interpenetration. It is currently being tested in the most demanding environments known to medicine, sealing holes in beating hearts and repairing leaking lungs, all while the organs are in motion. Because it mimics the slug's protein-based design, the human body doesn't reject it as a foreign object. It integrates, it heals, and most importantly, it holds. The impact of this shift is nothing short of transformative. For over a century, surgery has been fundamentally mechanical. If you have a wound, we sew it. If a vessel leaks, we staple it. But these mechanical solutions are inherently traumatic. They require piercing healthy tissue to save damaged tissue. Stitches create micro tears, and the staples, they can leak under the high-pressure environment of the cardiovascular system. This is where the biological shift changes the math of healthcare. By using a bio-inspired adhesive, one that creates a seamless, airtight seal, we eliminate the need for localized trauma. The economic data is just as compelling as the science. Current research suggests that uncontrolled bleeding and post-operative leaks increase procedural costs by up to $30,000 per patient. By moving to a suture-free model, we could see a 40% reduction in post-op complications. In the United States alone, where surgical supply costs have risen to over $57 billion annually, this bio-glue represents more than just a medical breakthrough. It is a multi-billion-dollar optimization. We are potentially looking at thousands of lives saved and a fundamental restructuring of how hospitals manage surgical recovery. But this slug's blueprint doesn't stop at the operating table. We are looking at a fundamental shift in material science. Currently, the global subsea repair market is worth billions, yet maintaining underwater infrastructure remains one of engineering's costliest headaches. Most industrial glues simply dissolve or fail to cure in high salinity, high-pressure environments. But by mimicking the slug's ability to displace water at the molecular level, researchers are developing amphibious adhesives. Imagine deep-sea cables, oil rigs, and even renewable offshore wind turbines being repaired by autonomous robots using bio-inspired patches that cure instantly in freezing salt water. Beyond the ocean, this research is fueling the rise of self-healing infrastructure. By embedding microcapsules of this hydrogel into concrete or composite plastics, we are creating materials that can bleed glue when they crack. sealing their own structural failures before they lead to catastrophe. As we continue to decode the brilliance of natural design, the humble slug, often overlooked and misunderstood, is proving to be the key to the next frontier of material science. It is a reminder that the most advanced engineering solutions on Earth aren't always found in a lab. Sometimes they're found in the damp undergrowth of a forest. This has been a Biofauna Report. Thank you for watching.